So welcome everybody to 2021. How exciting to be back with you on another edition of Webinar Wednesday, as Melissa suggested, the very first episode for the year 2021, a year that I'm sure holds plenty of promise and excitement for all of you. I know we're excited to be turning the page on 2020 and heading into a new year, and very, very optimistic about what the future holds. Great topic for you today, talking about the top 5 CNC learning systems. Well, if you're new to Webinar Wednesday, you know that we don't always take a direct approach to the topic, and sometimes we get there by a little bit of a roundabout way. Well, you won't be disappointed this week if you like that approach to Webinar Wednesday. We're going to start with a roundabout way again this week. And that roundabout way is this. I want to talk a little bit about some of my friends. Like many of you, I have plenty of friends. I'm proud to have plenty of friends, and a lot of them are, relatively ordinary people. They're great people. They're wonderful people, but not necessarily eccentric or peculiar. Fairly run-of-the-mill type people. And then probably like many of you, I have a handful of friends that I would call maybe a little bit eccentric, a little bit peculiar, certainly unique. And I want to give a handful of examples. So I have a friend who's legally blind. This is somebody who's been a friend of mine for about 25 years, give or take, legally blind. He's a member of the Coast Guard Auxiliary. He's probably, in fact, he is in his mid-70s by now. And as I mentioned, I've known him for quite some time. Has a total fascination with airplanes, boats, railroads, anything mechanical. He is a person who can literally, he can't see very well. He can hear an airplane going overhead and tell you what kind of airplane that is. That's a peculiar thing, and he's a peculiar, interesting individual. Certainly not your run-of-the-mill type person. I also have a friend who taught art at the University of Chicago. Now he's the program manager for an artist's house in the greater Milwaukee area. He's not like most of my other friends. He's a little bit eccentric. He certainly has a background that's different from mine. Really, really fascinating person and a great, great friend of mine. Now, as some of you know, I raced bicycles for a number of years. Think the Tour de France, but at a really, really amateur level. But I did that for a number of years. That sport tends to attract some eccentric people. And I met some really, really interesting people during my years of cyclocross racing and bicycle road racing. I have a good friend who turned his garage into an arcade. His garage, he literally doesn't park his car in his garage. If you're familiar with the weather in Wisconsin, that can get a little bit dicey. He leaves his cars outside, and his garage is an arcade. He has a pool table, several pinball tables, all of these different arcade games that you would see. And he has an interest in collecting interesting things. He's got a huge 45 record collection. Right now, he's on this kick where he's collecting signed album covers from the bands that he likes. Really peculiar guy, a wonderful person, a great friend of mine, but certainly out of the ordinary. Finally, I have a good friend who's a real estate broker, but he's also a ski guide. So he spends his time out west guiding people on their ski vacations in the winter, and he's a trout guide in the summer. Not like most of my other friends. He has a really, really interesting life. And I can tell you that having friends like this, and I'm sure you feel the same way, makes life more rewarding. It makes life more interesting. I have a penchant for people who are a little bit odd, who are willing to do things a little bit different, who aren't necessarily following the status quo. And I think that makes life, as I suggested, way more interesting. So as we turn our attention to the world of CNC programs, let's think about this. In as much as I like people who are different, I like people who are willing to try something a little bit different, to do things their own way. Have you ever noticed that all CNC programs look the same? And I put the word all in parentheses, or in quote marks rather, because not all CNC programs look the same. But I would tell you that if I walk into the CNC program in 90% of the colleges in the Midwest, I see exactly the same equipment. I see exactly the same way and the same methods of teaching. And then there's the other 10% that are willing to do things differently. Now, look, I'm all for standardization in education. If we can share best practices and find a best way to do it, and then leverage that best way by spreading it across lots and lots of different schools. But I'm also in favor of people trying new things and figuring out what that best practice is. Because the truth of the matter is, if none of us are willing to try anything different, we'll never push the envelope, we'll never evolve, and we'll never get better. So as we think about kind of that cookie cutter CNC program, I'm going to introduce some topics and some technologies today that not all of you have seen. Some of you have these, some of you are using them in your program, but not all of you have. And I'd like to introduce you to some of these interesting technologies. So we're going to go through the top 5 CNC learning systems. Let's start with number 1, Now, about 4 years ago, I was in Japan and I was visiting a company. That company probably isn't a secret based upon what you see there. Now, I don't know if you know what you're looking at. You probably don't. But what that is two side by side parts that are about the size of a regular baseball, like a hardball. So think about a hardball, a baseball, and those have been machined to a finish that is literally like a mirror. And so, as what you're looking at is that baseball that is reflecting what was behind me as I was looking at it. Absolutely fascinating. And as I was marveling over the finish that was machined onto that piece of steel, a gentleman walked up to the display case and I said, "How did you do that?" And he pointed his finger at a piece of equipment and he said, "That's how." And he pointed at a Fanuc Robo drill. And we started talking about the Fanuc Robo drill. And I took a picture of it. And he said, "That is the machining center that machined the case for your iPhone that you're using to take that picture." I said, "Really?" He said, "Yes, every single iPhone across the globe. The enclosure, the case has been machined by a Fanuc Robo drill." Now, it probably isn't any surprise to you that the company that does that is doing really, really well. It's a company called Foxconn. They're the largest contract manufacturing company on the planet. This was released just yesterday. Foxconn released their December financial statements just yesterday. Would you believe in the fourth quarter of last year, in the last 3 months, they billed $72 billion in revenue, billion with a B. That is how much revenue they billed in one quarter. A $72 billion company would be a huge company if that was their revenue for 1 year. That was Fanuc's revenue for one quarter. Why? Because they machined so many Apple iPhones that are prepared for 5G, the Apple iPhone 12, that drove the revenue for their entire quarter. And so all of those parts, every single one of those enclosures was machined on a Fanuc Robo drill. Now, some of you know that I have a fascination with Industry 4.0 technology. I'm not going to cover every single aspect of the Robo drill, but one of the reasons that machine can machine a part to such a fine finish is that it uses artificial intelligence. It uses artificial intelligence for its thermal displacement compensation. It uses artificial intelligence for its contour control. That control standard can read ahead 30 blocks in a program and adjust the machining center for what's coming down the path in the CNC program. There's an option that enables it to read ahead 200, that's right, 200 blocks, and another option that allows it to read ahead 1,000 blocks, reading ahead 1,000 blocks and programming and adjusting the machining center to machine that high precision, high speed finish that you see on that particular part. Now, the Fanuc Robo drill is actually a really, really cool piece of equipment. We have a number of community and technical colleges that are already using those. But one of the things that we can use along with the Fanuc Robo drill is what we call the MTech. And what this enables us to do is to teach robotic loading and unloading of a machining center. So one of my pet peeves is when I walk into a machining company, a CNC company, and the owner is complaining about how they can't find great people. And then we walk the floor and I see their best machinists loading and unloading machining centers. That makes absolutely no sense to me. If you're really constrained that much for labor, if you're really constrained that much for great talent, why are you taking some of your best people and having them do work that can be performed by a robot? We need to teach this technology in our community technical colleges and even in our high schools. How do we load and unload a machining center using a robot? Along the way, we're teaching robot operation, robot programming, jogging, dual check safety, end of arm tools, all of this technology that goes along with robotics. And so if we're not teaching that machine tending, that loading and unloading at our community and technical colleges, that needs to change because we need to start driving our industrial employers toward understanding this technology, having people that are available to be able to leverage this technology and putting it to work and helping solve the skills gap in the world of machining. So that is number one. Number two may not seem that unique. Number two is a machining simulator or a CNC simulator. Now, many of you see these, many of you have these, and you look at that and say, really, that's number two CNC learning system? My answer is yes, if it is a simulator that gets used. And I can tell you that this simulator that you are looking at right now gets used. Full 3D graphics. So we're not just looking at a 2D picture of the part, it is a 3D part. And we are machining that part using G code and M code that's been programmed into that machining center. If a student screws up, we can actually crash that machine. We can take the tool outside of the tool path. Real machining sounds, it's going to sound exactly the way a machining center will sound when we are machining or milling a part. And it is a very, very realistic experience. We can take a program, create it on the simulator, and put it on a USB drive, take it over to a machining center and machine the part. It is a phenomenal way for students to learn machining without being on the machining center. And especially today in this day and age of social distancing and spreading people out, having them working on multiple machining centers that may cost a couple or a few $1,000s a piece can be much, much more economical than having them learn on a machining center that is $20, $30, $50, $70,000. So that is a great tool for teaching machining and teaching CNC, assuming that it's used. And I can tell you that this particular simulator, because we see them all over the Midwest, this gets used by students. Now, the other point, though, is that a $2,000 or $3,000 machining simulator may still be a lot of money if we have a cohort of 16 students going through the machining program. And so if we can't afford that machining simulator, or even if we can, another great option is number 3. And number 3 is what we call NC Guide. And this is essentially a network-based machine control that a student can utilize to learn all of those same things that we just talked about. Just like that machining simulator, we can also teach Manual Guide I, that's conversational programming, and we can teach conversational programming using NC Guide. It is also a fantastic instructor tool. So our instructors can stand before the class, run this on a computer network, and show the students exactly what they want the students to see as they are going through the program. We can teach milling. We can teach turning. We can upload programs and download programs just like with the machining simulator. So we can actually take a program, create it in NC Guide, and put it on a machining center. And get this platform lives on the school's computer network. If a student has access to the network from outside the school, they can use NC Guide from home, from work, from wherever they do their studying, just by having access to the school's computer network. And so again, in this day and age of distance learning, of flipped classrooms, this is an incredible tool for our students, an incredible tool for our CNC programs. Top 5 CNC learning systems, number 4. So some of you know that I write the monthly leadership column for Production Machining magazine. I've been doing that for quite some time. That magazine is published by Gardner Media. My relationship with Gardner Media goes back now 16 years. It's been 16 years since I've been writing leadership columns for that publisher. They also publish a magazine called Modern Machine Shop. Many of you are regular readers of Modern Machine Shop. And if you are a regular reader of Modern Machine Shop, you know the column CNC Tech Talk. That column, CNC Tech Talk, is written by a gentleman by the name of Mike Lynch. Mike Lynch is a personal friend of mine, incredibly well respected across the world of CNC, across the world of machining. He is an absolute expert on CNC machining and on machining in general. Well, Mike has created a really solid group of lessons in e-learning to teach CNC. 24 lessons on milling, 28 lessons on milling, teaching programming, setup, operations, offsets, every single aspect of CNC technology that you can think of. And it's just a phenomenal program, really solid for preparing students for industrial certifications. And it is available online. So this is another platform that we can deliver using an online modem. We don't have to deliver it necessarily at the school or in the classroom. So again, in the day and age of flipped classrooms, of distance learning, a really, really solid solution. Now, I've talked over the course of the last several months about our journey through the SACA certifications. I actually earned several Smart Automation Certification Alliance Industry 4.0 certifications this year, or last year actually. Melissa did as well, as did most of the members of the ATS Lab Midwest team. We learned that and we earned those certifications using a platform from Amatrol, which also includes some really, really solid CNC introductory technology, also includes curriculum that will prepare students to sit for example, the NIM certification in CNC machining. So that's another really, really solid option when it comes to teaching CNC. So is everybody ready for number 5? This is the one that of all these topics that we've talked about, probably the one that I'm absolutely the most excited about. The number 5 CNC learning system comes with the subheadline, "What did you get for Christmas?" I can tell you I got some really great stuff for Christmas. It was a wonderful time to spend time with my family, to give some really interesting gifts, to receive some really interesting gifts. But I also bought myself something for Christmas, and it hasn't arrived yet. It arrives on the 28th of January. What I bought myself for Christmas was one of these. And I bought it for myself and for our entire team at ATS Lab Midwest. That is the Level EDU mill. Let me tell you what this thing is. It is a mill. It is a CNC machining center, but it is also a 3D printer. It enables us to combine all of the best aspects of additive manufacturing and subtractive manufacturing to create really, really intricate parts really, really efficiently. This is just a phenomenal piece of technology from LaVille. We have one arriving at our tech center in just a few short weeks, and I cannot wait. Now, some of you might look at that and say, yeah, that's kind of cool, but 3D printer, machining center, that's kind of a toy, right? That is anything but a toy. That has 7.5 inches of travel in the x-axis, 10.5 inches of travel in the y-axis, and 5 inches of travel in the z-axis. It has a work table that is 17 inches by 10 inches. And as you can see on the right-hand side, it has a Fanuc control. One of the reasons that I am such a huge advocate for Fanuc is that I spent 20 some years in manufacturing. I don't care what anybody tells you, the control, the CNC control that your students will see when they get to manufacturing, and I can tell you this anecdotally and with data, is a Fanuc control. Two-thirds of CNC controls in machining, in manufacturing, are Fanuc controls. The machining centers that I had when I was in manufacturing all had Fanuc controls. When I walked through manufacturing facilities around the Midwest, more often than not, and it isn't even close, what I see on machining centers is a Fanuc control. And that is why I am such a huge advocate for Fanuc, because why don't we teach our students on the same technology that they are going to see when they get to industry? Why would we put our students in a position that when they leave our programs and end up at a company that is doing machining, that they're seeing a control that they've never seen before, that they have no experience with? And I can tell you that students that have left technical college programs and gone on to work in the world of machining and they encounter all those Fanuc controls will tell you it is a good 40 hours at least for them to get comfortable with that Fanuc control before they feel like they are as proficient on it as something else that they might have learned on in technical college. I'm not saying that every control in a machining program needs to be a Fanuc. What I am saying is that we do our students a disservice if we don't give them tremendous amounts of exposure to this control as they're going through their learning at the technical college level. So this particular machine, this is why I'm so excited about it. It is a full industrial CNC machining center. It has a 2.2 kilowatt 24,000 RPM spindle. And here's the most amazing thing. That will hold tolerances of 4/10. For those of you that don't know what that means, take out a pencil and a piece of paper and write down 0.0004 inches. That is the tolerance that that machining center is able to hold. And it is also a 3D printer. It will be able to create the most complex parts. This belongs in every single fab lab. This belongs in every single 3D printing and mechanical design program. And this belongs in every single machining program. And it belongs in my tech center, which is why I bought one and I'm putting it there, and it will be there for you to see in 3 weeks. So those are our top 5 CNC learning systems. Have a look at that Robo drill, the ability of that thing to be able to create high speed, high precision parts, do it really, really quickly, and machine parts to that finish that we saw in that softball looking thing when we started this presentation. Add that MTech to it, and you've got robot loaded machining using the same machine that machined your student's iPhone. Number 2, the Fanuc CNC machining simulator, full 3D graphics, G-code, M code, the ability to crash, realistic machining sounds, and we can actually output this to a separate screen if we want to that functions exactly as a machining center would. Number three, NC Guide, a great tool for presenting to your students. We can have up to 16 students at a time working remotely outside of the school, programming a CNC control and being able to download their program and put it right on a machining center when they get to school. The next one, CNC Concepts, Mike Lynch, who writes that great column for Modern Machine Shop, created phenomenal CNC curriculum. It's available digitally, again, great for this age of digital media and of a flipped classroom. And finally, don't forget that EDU mill from LaVille. This thing is phenomenal. I'm going to have one in just a few short weeks. It is not just a machining center and an industrial grade machining center. It is also a 3D printer. So I hope we've given you some things to think about in the world of machining as we look at how we can make our programs more unique, as we look at how we can create more industrially relevant experiences for our students, and as we look at how we can do things our own way and share best practices among machining programs. These are some things that are worth thinking about here in 2021. I want to thank all of you for joining us for this edition of Webinar Wednesday. You're not going to want to miss next week's either. We have a really, really solid guest. One of the things that I'm really, really passionate about is how do we take students from disadvantaged or underserved populations and create great pathways for them in the world of industrial employment, in the world of advanced manufacturing, in the world of robotics. If there is one way that we can use to solve so many of the problems that we face in our society, it's by creating awesome, family sustaining, life supporting, interesting jobs for people who would not have otherwise had access to those types of opportunities. We are going to interview next week, and I'm not going to be on the program next week. Actually, we have both Melissa and our very own Mike Dietrich being joined by a representative of an urban school district who is doing what we just talked about, finding ways to teach robotics, industrial robotics, to students from disadvantaged communities and creating really, really amazing career opportunities for those students, whether it's direct to workforce, onto a technical or community college, or off to a four-year university engineering program. So you won't want to miss that episode of Webinar Wednesday. For now, thank you so much for joining us this week, and don't miss next week's edition either. Thank you so much.